Hello Internet! In this video I want to take a look at a way you can build 2D maps using textures. And so the idea here is we're going to map specific colors in a texture into specific game objects. And so this sort of represents the different tiles in our map. And so this becomes a really simple way, I guess, to represent a more complicated set of data in a visual way. And so the advantage of this is if you're talking about like paths, for example, or city layouts, it can be kind of hard to tell what that means when you're looking at like ones and zeros. But when you're looking at actual data, it can become a little bit more intuitive and it makes a little bit more sense. Plus, this gives us a lot more options because we're working with colors. So we actually get the full number of colors as options in our map rather than just 0 and 1. I guess you could increase the number for the integers, but it becomes a little bit, in my opinion, less useful just because you're dealing with like an abstraction of those numbers rather than something that kind of represents a little more closely what you're actually dealing with. So in this case, I have 5 objects here. I've added them to the scene. They're just prefabs at this point. And on the right, I have this map builder. And so this is mapping white, black, red, green, and blue, just the peaks of each of those to a specific instance type or game object. And so the idea is when we read those specific colors out of our texture, we're going to create an object at that tile location in our map. And so hopefully we can turn this set of data into an actual thing. There's better ways to do this, but demo. And so the idea here is mostly just to like introduce this concept. And another useful thing, like you might be asking, why would you use this in say Unity, like I'm doing, when Unity gives you a full editor? That isn't always the case if you're working with something like Monogame or some Java engine or something you've rolled yourself. You aren't going to have all of those tools to use. And so this gives you a way to kind of integrate them yourselves. It also gives you a way for users to import new maps into your game. All you need to do is have them give you a picture and you can turn that into a map. And so that becomes a little bit more useful for people who want to actually build their own models and sort of mod their own maps without implementing a full modding support. So those are some of the advantages, I guess. There's definitely a whole bunch of different ways you could store map data. This is just one of them, and it's really suitable for tile sets because the texture is already sorted into a tile set. Like it's already just a set of colors. And so all we're doing is changing those colors into objects. And you could do more with this. Like in this case, I have like a grass and some stone here or dirt, and some like swampy stuff, whatever that is, and some like blocks. Each of those are individual objects, but if you are working with the tile set, they typically have like borders and things that are dependent on looking up the nearby objects. When you're working with an editor, it isn't always easy to get those border things to work the way you want. This makes that pretty easy because we can actually just look them up. I haven't done that here, but maybe in the future we could take a look at that. Basically, all you need to do is look at the tile to the left or right of it, or above it, or below it, or wherever however your tile set is designed to work. You can just look at the tiles that impact the shape and use that to influence what tile you actually use to draw that specific thing. But anyway, that's enough of that introduction. This is what we have right now. This is just a serialized list. Unity, unfortunately, still doesn't support dictionaries in its inspector, which is really disappointing. But we can kind of hack it. And so this is the hack. This is just a public class that stores a whole bunch of things. We have to mark it as serializable so Unity can actually import that. And then once we do that, we get this list. And so a list is just going to be an array list of map objects. The reason this is a downside is because it means we actually have to translate this into a dictionary for it to be more useful for us. That's not strictly required. We could ignore that. But searching over a list is slower than searching over a dictionary, because when you're searching over a list, you have to iterate over the entire list. Whereas if you're looking into a dictionary lookups are typically O of 1, which means that they're going to be a constant time lookup. And that's just because of magic. That's maybe not the best description, but dictionaries use a hashing algorithm that allows them to more easily find where things are inside of them. And so by using that, you can actually get accesses to objects much faster. And so we don't have to iterate over this entire list. That doesn't really matter. It's actually probably not going to make any difference at all for a list of 5 elements. But when you're talking about bigger lists, like lots of objects, like if you have a big game, you're going to be iterating over every type of object that could exist. And that might be hundreds or thousands of things. And so when you're talking about that and doing that for every single tile in your game, you're doing a lot of lookups. And so if you have to do 1,000 lookups instead of 1 every single time, it's going to be much slower. And so that's why we want to use a dictionary here. So what we're going to do is make that dictionary. So this is going to be a private dictionary. And we're just going to take that map object that I created, and that's not how that works. We're gonna map that and just effectively deconstruct that object into a map of the color and the instance. And so this will be our map tile dictionary. Sure. And then in start, we just need to initialize a dictionary. And so that function needs to do something. Let's do, what the heck? Doing all sorts of things. There we go. Generate the right method. And this can be private. We're probably not going to need to invoke this ourselves. It's just a helper function. It's just there to make it a little bit easier for us to separate this stuff and do this implementation by ourselves instead of having to do everything else. And so what we're going to do is say map tile dictionary equals a new dictionary. My spelling is awful right now. Of color and game object. And so this just creates a brand new empty dictionary. There's nothing there, which is great. And then what we're going to do is for each object, let's do tile in our map instances. We want to add it to our dictionary. So we're just going to do, how do we want to do this? There's an edge case here of we define 2 colors or 2 of the same color that map to different objects. That doesn't work because it should just be a 1-to-1 relationship of colors to object types, or at least there should only be 1 color of every color. Phrasy, but anyway, we're gonna just go for it. So we have map tile dictionary dot add, and we just want to add the tile dot color for the key, and the tile dot instance as the instance, I guess. And so this is going to build our dictionary. And so there is, again, an issue here. We should check if our map tile dictionary has contains key. There we go. All languages have different syntax for this, so I always get confused. But we're just going to do tile.color to look that up and just pass that in. And so if it doesn't contain the key, there we go. Let's add that exclamation point there so that we actually make sure we're doing this right. But this is going to say if we don't contain a key already for that color, then add that key. Otherwise, we want to throw an error. So else throw an error debug.log duplicate colors found. And we'll just add our color here. So tile.color. Sure, that should be fine. Like, again, probably want to actually handle that in some better way, because this probably shouldn't happen if your data is correct. But if it does happen, you want to do something about it. There's other things that could happen, like tile.instance being empty. I'm not going to deal with that, but you probably should if you're going to do that. But this is just some safety just to make you aware of it, I guess. All right, initialize tile dictionary, that's done. And then we want to generate map. Sure. Let's not comment it out. Generate a method. Let's move it below. And we're not going to actually need an update here. The update isn't going to be called because we aren't going to update anything. We're just going to generate the map, and then we can probably just destroy this. Sure, why not? That's just going to delete the script, so it's not there anymore. And that's sort of, I guess, cleaning up after ourselves. We probably don't need to do that, but we're going to do that anyway. There's not too much that would be happening anyway, but this way it really isn't going to happen. So anyway, generate map. This we don't have enough information for. We actually need our texture here. And so I'm just going to plug in a texture. And so this is going to be our map. And we're going to have a public float of spacing as well. But you could just have this map be some variable. Maybe it's a file path or something, and then you ship a bunch of files with your game or something. However you want to look this up. In this case, I already have a texture in my game files, so we're just going to use that. And we're going to have a spacing, which is going to be the amount of space between each of these tiles. And then we're just going to use the current transform.position of this object as 0, 0, and then we're gonna just move from there like that. So we'll see how that goes. Generate map is going to be for int x equals 0, while x is less than the map dot width. Sure, we'll just increment x. And so map.width is going to be the number of pixels wide the texture is. So this is going to iterate over all of our width pixels, all of the columns in our texture. And then we need to do the same thing for all the rows. There we go. So we'll swap this out for y's and just do map.height. There we go. So int y equals 0, all of this fun stuff. And then all we need to do now is actually create our game objects. And so the first thing we need is a position. So vector3 tile position is going to be equal to a new vector3 at x times the spacing. And then here we need to decide, I'm using a 2D space, which means y is actually going to be up and down. In your 3D worlds, if you're doing 3D, you'd want to do this on the z-axis because that would be depth. But we don't have depth because we're doing a 2D game. So we can actually use this y here. So y times spacing and just set 0 for the one we're not going to use. So again, I'm using this for 2D stuff. So 2D tile maps. In 3D, this gets more complicated, and I'm not entirely sure this is a good idea for that. But for 2D stuff, like Zelda or whatever else you're making, it kind of makes some sense. So we're going to try it. So that's our tile position, but that's a relative tile position. So maybe we should rename this. I think it's, yeah, relative tile position. That was me hitting F2, by the way, on Windows. And I think on Mac, that's the same hotkey, but that's the rename symbol shortcut, which is actually going to, if I had other ones of those in my scope, it would rename those symbols as well. So like if I wanted to rename Y, for example, to YY, we just renamed all of our YYs in our thing to that. And we can do, I think, Control F2 is going to select them. So now I have a cursor at the end of all of my Ys. If I just hit delete, I just deleted them all, but I can just type Y. And now we've done that. So there's some handy shortcuts. I use those. We didn't want to do that. There we go. Don't hit enter after you do that. It just gives you, in Visual Studio Code, you can have multiple cursors if you want to edit symbols like I just did. And so, yeah, if you hit enter, you're just going to get a whole bunch of extra spaces. Anyway, enough distractions. Let's do a new instance. So game object, that's not how we do this. Instantiate, there we go. And now we need to create our object. And we don't know if we need how to create that object yet. So we need to look it up. So this isn't quite going to work, but we're going to do our tile at our tile position plus our current position. So this dot transform dot position plus the relative tile position. So we're going to take wherever this current map generator thing is, and then build a bunch of stuff in the positive X and Y directions. And then for the rotation, we don't really care about that. What we can do is do quaternion.identity, which is going to be the no rotation, just the identity, which is a short for the thing that doesn't do anything. That's not really what it does, but anyway, you could give it the actual rotation for this object, but that wouldn't actually work. It would mean that if we rotated this, all of our tiles would rotate, but they wouldn't line up anymore because we're not actually rotating this thing. The relative tile position isn't rotating. And so because we're not rotating that, it wouldn't be correct. So we're not going to do that. And there we go. It's at a semicolon. That should be good. Now we just need to get this tile thing. So var tile equals, and then here we built a map for this. So file map tile dictionary. And this might not be the best way to do this, because I think we can do something like try get value. There we go. Try get value for the color. And for that, we actually need this to be a game object of our tile. I'm going to leave this empty, and we're going to do if I can spell it correctly, that's one of the conditions for this if. If map tile dictionary.tryGetValue is going to return false if it doesn't get anything. So if we don't have this key in our dictionary, it's going to return false, and we're not going to create a map tile. So tryGetValue blah, and we need to give it two things. The first is going to be the color, and so for that we need to do map and give it, I believe, how do we get the pixel? I forget. Texture ID, nope. We're using a texture, that's why. Texture 2D is the correct thing we want, because texture is like the abstract texture thing, and that can represent more than just a texture 2D, like a 2D texture file. That can also reference like render textures, which are different. And so that sort of gives you an abstract thing. We didn't want that. So in order to get that, we should be able to get more stuff. Here we go. So we want to get pixels, or get pixel. There's also a get pixel bilinear, which is going to do some interpolation for you, and that accepts a UV value. So if you've done shaders before, UVs are going to be between 0 and 1 along the texture, and so you can actually look up values in between two textures. We definitely don't want that because we're using specific values of this texture. And so if we were blending between two textures, we would get the wrong thing. So we're just going to get pixel of our color. Not that. We're going to do get pixel of X and Y. There we go. And that plugs in our color. And now we need to provide an output value for this value. And that's going to be our tile. And so if we label this as the output, we're going to get that written out to this tile object if this finds a value. So if it returns true, we're going to get a value. And let's do that. All right, there we go. There we go. All right, so we have our tile coming out here. And so we found a value. Our tile has a value. Now we get it here. Otherwise, we didn't find a value. And so we want to debug.log error map texture could not find color in map. And we want to give it, I guess, something else. So we're going to do X plus blah plus Y. Could do string interpolation here. We probably should, so let's do that. So we're going to put a $sign in front of this, and then we're going to do that and that. And so this is no longer correct. So we can just drop all those values. And what this is doing is taking this string of values. So we have this map texture could not be found in the color map or whatever I wrote there. And then we're giving it these brackets and then a variable. And so in this case, we have X and Y, which are coming from here and here. You can see it's saying they're ints. And so this is sort of a way to read in extra value from the scope of wherever you are into your strings. And that happens when you put a $sign in front of it. There's another thing, the @ which is an explicit string, I believe. I don't know if that's the correct term, but that actually lets you, if you put new lines into your string, for example, it's going to read those as new lines. So that is a way to like format text a little bit more, but we'll leave that there. I think that's everything that we need. That should do our generate map. We should get things instantiating if we did that, or a bunch of errors. And so I guess we can test this. We just wrote all of that in one go, so this is going to go great. I'm going to drop all of those prefabs because we don't need them. And we're going to stick this at -8, 0, 0, and -8. My light is really bright for some reason, and I can't read the top right of my screen. So we're going to pretend like I entered the right values there and hope that this works. And so I have this levels folder with just this one thing, and I can probably, let's see here, do a material just to show you what this actually looks like, because otherwise it's too small. Or this will work. It looks like this. There you go. So I just made this in Photoshop really quick. Each of these maps to different things, and so we should see like these kind of patterns from our sprites. That's sort of what I'm hoping to get out of this. And I just kind of tried to throw things together in some sort of an interesting pattern. I didn't really have an idea. It's not really a map. It's more just a pattern, but you know, it's a thing. So we're gonna do the thing. Yeah. So let's attach the sample level to that and give it a spacing of 1. And so this is 16 by 16, I believe. Yeah. So we should get 256 things. Is that correct? That might be too small. We're going to get a whole bunch of instances when we do this. But first, I want to point out I changed a few things here. I'm pretty sure this doesn't matter, but I turned the filter mode to point. So this is going to actually render point level things and not do any filtering between them. We talked about bilinear filtering. That's where this comes in. This should only be when it's rendered on like a mesh or something, but I turned that off anyway. I also turned off MIP mapping, which is done to like get reduced quality levels of the texture for further away distances. We don't need that either because we're using it as a lookup texture, so I can save, I think I was 0.2 kilobytes, so I cut off 1/5 of the size of this file by removing those. And what else did I change? I also changed the compression so there wasn't any. I don't think that actually affects it, but we can play with that after we see if this works. So let's give that a shot. So let's see what we get. Something interesting. There we go. So this is that same texture. You kind of get the idea, right? That's too small. It's this. So we get that same thing just here in a map that we can actually use. And so you could actually use this, write this into some other file system or something that actually knew how all of these different tile sets should interact and actually get something that looked a little bit nicer. Maybe you want to blend these blocks. So it's just one solid wall, for example. Or maybe you wanted like smooth transitions between the grass and this dirt. You could do that as well. So there's a bunch of things you could do with this to make this look nicer, because otherwise we're just inserting a bunch of tiles. But this gives you a way to turn, I guess, Photoshop maps, or I guess you could edit this in Paint or anything that lets you change pixels into a map, into something that you could use in your game. And these are all just game objects. So we could add whatever we wanted to these and make them do anything we want. You can use this to signify like spawn locations for players in your map, or things like that. Pretty much anything you want. The only difference is you only get as many colors as you can use, and they all kind of overlap. So if you want to embed multiple different types of data over one another, you need to start allocating channels in your colors. And so that can get a little bit more complicated. But for like basic stuff, if you're just creating a basic game and you need a tile set and you want like people to be able to upload their own, this might be an option for that. So that's sort of part of the goal here. But hopefully this kind of gives you some ideas on how you could use this. And maybe if you do use it, let me know in the comments, or come to our Discord channel and let me know, or follow me on Twitter and shout me out. But yeah, that's pretty much it. That's pretty much everything I wanted to cover. So if you have other ideas for things that you want to see us cover in the future, or you take this and make something awesome with it, let me know. And until next time, I will see you then. Yeah, this is a good outro. This is definitely going great. Anyway, see you, Internet.